In the previous class, we were discussing about the different operations or mathematical operations, how we can do that if we have the binary information, right? So we try to calculate like how we can perform the binary addition, binary subtraction, binary multiplication, and binary division kind of things. Okay, so this is what we have done it. Now, one important thing that we have to consider, especially like if I'm considering the binary number systems, which is an important number system for the digital system design. So the complement of any information is also equally important, and that we need to consider. What does it mean? What is the importance of complement? Complement means, like, suppose I have information like if it is 0, then after complement it will become 1, and the vice versa. Okay, so the complement means 0 to 1 and 1 to 0 conversion. Okay, so basically why we need the complement form in the binary number system. So the first and important point or important reason behind the complement to calculate the complement of any function is to simplify the subtraction operation. Why it is so? Because we know that if I have to subtract something from any number, then because see, in any of the digital system, there is no any operation like subtraction. You have to perform just like an addition. You can add it, but you cannot subtract in the digital systems. Okay, but this complementary form of any number will help you to get the results just like a subtraction, even after performing some addition operation. Okay, how we can do that, I will tell you in more details, like how we can perform the subtraction operation with the help of complementary function without any subtraction. Okay, so I will explain each and everything in more detail. So this is one of the important reason. The second one is to represent the signed number. Okay, so the complementary is important. Why it is so? What is the signed number? Signed number means, like, suppose I have a number like 1, 2, 3, something like, without any sign, whether it is positive or negative, we don't know. Okay, so if I am representing that number in the binary number system, that we call it the unsigned number system. But if somehow I want to represent any number, because see, if we have information in decimal number system, we can easily write plus or minus sign on paper, that this number is negative or this number is positive. But how the computer system will understand whether this number is positive or it's negative? Okay, so the complementary form is also equally important, like how it can be represented, how it can be utilized to represent the number system or the signed number system, whether the number is negative or the positive number system. Okay, so these two are the important reason to understand the complement of any number in the binary number system. Okay, so if I'm talking about the complement, I just told you these are the two reasons why we need to know about the complementary. Basically, there are two types of the complement of any binary information. Suppose I have information, so I can calculate the complement, and we call it r-1's complement. Okay, so this is one kind of complement. What is this? I will definitely tell you, and how to represent the number in this r-1's complement, I will tell you in more detail. The second kind of the complement, that could be r's complement. R here is the base. Like, suppose if I'm talking about the binary number system, so here binary, for binary, this r is equal to 2. So r-1 means ones. So I'm talking about ones complement and twos complement. Similarly, if I'm talking about the decimal number systems, in that case, the decimal for the base for the decimal number system is 10. Okay, so in that case, I will talk about nines complement and the tens complement. Okay, so these are the two types of the complement, especially in the number system representation. Okay, because if you see here in r-1, what we are doing, whatever the number we have, we are subtracting from its base or its radix. That is why we can call it radix minus 1 complement. So this is, we also call it the radix minus 1 complement, because we are subtracting 1 from the base or the radix. Okay, second one, like r's complement, because we are truly complementing the number, right? So we can call it the true complement. So these two are the complementary function. Now let us discuss one by one what is r-1's complement, how we can calculate the r-1's complement of any number system, And then we will talk about what is the r's complement of any number system. So we know what is the importance of a complement form and what are the different types of the complement form. Now let us discuss one by one. Okay, first let us discuss r minus 1's complement. Suppose I have a number n with a base r. Then if I have to calculate r minus 1's complement of that number n, then this is the simple formula to calculate the r minus 1's complement of this number, where this r is the base, small n is the number of digits in the integer, m is the number of digits in the fractional part, and here this capital N is the number of which we have to calculate r minus 1. Okay, so suppose I have some number, something like that. Yeah, so this is the important thing you should know. Like the small n, the capital N are like small n is the number of the digits in the integer part, and capital N is the number which we have to calculate r minus 1's complement. And small m is nothing but this is the number of bits or number of digits in the fractional part. If there is no fractional part, this m will become 0. So this whole part will become 0. Okay, so this is what we know the things. Now let us try to consider some examples and try to calculate the r minus 1's complement for some of the number systems. Let us assume I have a number, if r is equal to 10, like let us consider the base is equal to 10. Base is equal to 10 means r minus 1 means that will become 9's complement. Okay, so let us try to calculate the 9's complement of any number. Let us consider I have a number which is 783.45 in the decimal number system representation. Okay, now what I have to do? If I have to calculate the 9's complement of this number, then what I have to do, simple thing that we need to do here, I need to keep this r is equal to 10. Okay, here let me use the highlighter. Okay, so here I need to replace this r with the 10. Here n is nothing but this is, if you see here, number of digits in the integer part is 1, 2 and 3. So this is small n will become 3. Here this r is 10. Then here this r will become 10. Here this small m is nothing but this is 2 because we have two numbers or two digits in the fractional part. And here r will be 10. And then this n is nothing but whatever the number we have here, 783.45. Okay, so after putting all these things, like after putting all the values in this formula, whatever we have written over here, the value will be 9's complement of this number will be 10 to the power 3 minus 10 to the power minus 2 minus 783.45, and the base will be 10 for whole number. Okay, and if we try to solve this number, we will get something like 1000 minus 0.01 minus 783.45, and the resultant we will get 216.54. Okay, so this is how we can calculate the 9's complement of any number which is given in the decimal number system. Similarly, if I have to calculate the r minus 1's complement of any number which is in the binary number system, then how we can calculate it? Okay, so let us assume if r is equal to 2. In that case, we can call it 1's complement because r minus 1 will be 1. So that will become the 1's complement. So if I have a number, something like this, let us assume a number is 1101 with base 2, which is represented in the binary number system. So if I have to calculate 1's complement, then what I have to do? Simply, I have to replace this with the r will be replaced with 2. And then we have to check all based on this formula. I have to write all these things accordingly. Okay, and then after calculating these things, yeah, see, the important thing is, even though we have this is in the decimal, like see, 2 to the power 4 is nothing but this is equal to 16. Okay, in the decimal number system, but I have to convert that number into the binary. So this is important. Okay, so that is what we have done here. The 16 can be converted into the binary number system, and this the equivalent of 16 is 10000 in the binary number system. Similarly, to the power minus 0, that will be 1. So 1, the binary of 1 will be like 0, 1. Okay, minus 1101, whatever we have the number here. So we have to do the subtraction operation of all these things. Okay, so we have to subtract all these things and we will get some number, something like this, which is 0010. Okay, just you can do it all at home, and then you will get the answer, something like this. Okay, so this is how we can calculate r-1's complement of any number in any of the base. Suppose if r is equal to, let us assume if r is equal to, if r is equal to 4. Okay, in that case, if I have to calculate r-1's complement, then I have to calculate 3's complement. Okay, so we can also do, we can consider any of this complement, any of the base can be considered, and with the help of this formula we can calculate r-1's complement. That's very easy, not that much tough. Okay, now because as of now we try to understand how we can calculate the 1's complement if the number is represented in binary number systems, and we understand how we can calculate 9's complement if the number is represented in decimal number system. What is m in this formula? M is nothing but number of digits in the fractional part. If you see, for r is equal to 10, 1, here we have 2 digits in the fractional part. So here this will become, m will become 2. Okay, so this m is like that. Okay, so this is how we can calculate it. But the important thing is, if I have to calculate the 9's complement and the 2's complement, in that case I have to do a long mathematics. Okay, but there is some short trick to calculate the 1's complement. Okay, what is that short trick? Let us try to understand this one. Let us start from the base 2 only. Here in the base 2, the actual number which we have is 1101. Try to observe the actual number and try to observe the results whatever we have received here. The actual number was 1101 and the received number was 0010. What was the observation? Can anyone tell you what we have done? Here if we see, yes, we have to just complement each digit. If it is 1, then I have to complement it with the 0 and vice versa. Okay, so this is what we can observe from here. Each bit has been flipped. Okay, 0 becomes 1 and 1 becomes 0, and this is a simple way to calculate the 1's complement of any binary information. Okay, and how to complement any number? We know that inverter is a simple logic circuit. Yeah, we will see in more detail, but you know, because you have already studied these things. So inverter is the simplest logic circuit that can complement the number. Okay, so suppose I have a number. Let us assume I have a number which is in base 2. So that number, if I pass this number system or this number through an inverter, then that number will become the complement of it, and this will be the in the binary. So this is nothing but this is 1's complement. Okay, so this is the 1's complement of actual number whatever we have. So for binary information or for binary number system, the simple technique is just complement each digit. Okay, so this is what you can calculate the 1's complement. But the question is, what is the short trick to calculate the 9's complement or other complement other than this binary? For binary, this is quite simple because we have only 2 information, 0 and 1. So we can flip both the digits. It's possible. But if we talk about the decimal number system, where number of digits are or number of symbols are more than 2, total number of symbols are 10. So how we can calculate it? Okay, so to calculate it, let us try to understand the fundamental of this one. Okay, if you see here this formula, okay, if you see this formula, in this formula, what you have done here, if you see, this particular part is based on the fractional part. Okay, 0.01 is coming out, and 1000 is coming from this integer part. Okay, suppose if I subtract, yeah, what this number says, if you see this number, yeah, this is the actual number, whatever we have. And if you see the first two part here, yeah, let me change the color. This is the actual number of which we have to calculate the 9's complement. And if you see this number, we are subtracting from some number which is coming from the information or number of digits. So this information is like 1000 minus 0.01. If we try to solve this one, so this will come something like 999.99. Okay, this number is nothing but this is 999.99 minus 783 point something. This is what we are doing. Similarly, let us assume if m is equal to 0, there is no fractional part. In that case, this term will become 1. If this term will become 1, so that will subtract from 1000 minus 1, that will become 999. Okay, so what you can see here, you can simply see here, if I'm talking about a 9's complement, so I have to subtract each digit from 9. Okay, so see here, whatever the example we have considered, we are subtracting each digit from 999.99. If there is no fractional part, then number will become 999. Suppose I have a number 783 only, which is in the decimal. Okay, so if I have to calculate the 9's complement of this one, so this, based on this formula, I will get 999 minus 783. That this will become the 9's complement. So the short trick is something simply like just you have to subtract each digit with from the 9. Okay, from 9, and then you will get the actual 9's complement. Similar thing will happen with other base. Okay, so you can calculate accordingly. Okay, is there any doubt how we have calculated the 9's complement, 1's complement? Yeah, so we try to understand two things. One is like based on the formula which we have to calculate. So if it comes in the examination, you have to go with this the long way, like based on the formula you have to do it. But like in the GATE examinations where the questions come something like that, so you don't need to calculate based on this mathematics. You have to just directly do it and you have to solve it. Right, so for that purpose you can opt this short trick. Okay, so in case of any doubt you can ask the questions, otherwise we can move ahead with the next kind of complement. Okay,
So this also works for fractional part also, like this
yes,
happens here also.
yeah, we have done it, right? So we had a fractional part like 783.45. Okay, so for 783.45 what we did, simply we got like this number is coming around 999.99. Okay, based on this formula, this term will be like 1000 and this term will be 0.01, because here m is equal to 2 and n is equal to 3. Here this is the n and this is the m. So based on that we will get something like that. And if we try to subtract like 1000 minus 0.01, that will give you 999.99. and this is what we are doing. We are subtracting each digit. I have a 5 digit in a number and I'm subtracting each digit from the 99999 only. Okay, so this is also possible for the fractional as well, and we have done it for the fractional. Okay, doubt is clear?
Yes, sir.
Okay, fine. So this can be done for the fractional as well as for the integer part, for both one. Okay, this is doable. So this is what the r-1's complement is. Now let us talk about what is the r's complement. Okay, as we know that r's complement is nothing but this is the true complement. Simply whatever the number we have, just like suppose if I'm considering the base 2 number, in that case I will talk about the 2's complement. If I have the base 10, then I will talk about the 10's complement, and something like that. Any base can be there, and accordingly we can say which kind of complement it is. Okay, so based on the base we can decide. Now let us talk about if I have a number and I have to calculate the r-1's complement, then r's complement, then how we can do that? Suppose if the n is the number with base r, then if I have to calculate the r's complement of this number n, then this will become 0 if n is equal to 0. Yeah, this is true, so there is no problem with this one. And the r's complement can be calculated with the help of this formula if n is non-zero. Okay, so r to the power n, r minus something like that. So this is the formula to calculate the r's complement for any number n here. Okay, let us try to consider some of the examples. Okay, suppose if r is equal to 2. Okay, in that case I'm talking about 2's complement. Okay, it means that I have to calculate the 2's complement. Okay, similarly, like let us consider the example. If n is equal to something like this, n is equal to 1101, whatever we have done in the previous slide. Okay, then we know that the 1's complement of this number will be like 0010, which we have done in the previous slide. Okay, and if I have to calculate the r's complement, then what we are doing, let us try to calculate the r's complement, and we will try to observe something, what is the outcome of this complement one. Okay, so the 1's complement will be like 2 to the power 4. Yeah, here if I try to put the values in this one, then 2 to the power 4 with base 2. So 2 to the power 4, like here like the number of digits in the integer part is 4, so that will become 16. Okay, and the actual number, and if I calculate this, that will become 10000 minus 1101. Okay, and if we try to solve this one, then we will get simply just, can anyone tell me what is the answer of this one, this subtraction? Can anyone tell?
Zero zero one one
0011.
one.
Yeah, perfect. Someone, yeah, Zain, yeah, you just told, right? So that will be 0011. Perfect. Okay, now so let us, yeah, so this number, whatever the number is coming, this number is nothing but this is a 2's complement of the number whatever we have written over here, 1101. Okay, now let us try to observe something. If we can recall the previous slide, in the previous slide we saw that if I have a number like 1101, in that case 1's complement was something like 0010. This was the 1's complement. Okay, now let us try to observe this with this one. What is the change between these two numbers? Can anyone tell?
So one digit is added in the ones
One digit is
added.
added. Yes, so plus 1 has been done. We have added 1 with the number whatever we have received. Okay, so if I add plus 1 with this number, I will get 0011. So what does it means? It means that if I have the r minus 1's complement of any number, and if somehow I will add plus 1 in that number, I can get r's complement. Okay, so the r's complement is nothing but this is r minus 1's complement of any number n plus 1, and that will give you the r's complement. So this is how the r's complement can be calculated. Okay, so yeah, simply suppose I have a binary number system, then I have to complement each digit, and after complementing, if I have added 1, then that will become r's complement. Okay, so this is a simple technique to calculate the r's complement of any number. Okay, so if there is any doubt, then you can ask the questions. Otherwise we can move ahead with what is the importance, or what is the use of or what is the application of this complement number. Okay, so we'll talk about that thing.
Excuse me, sir.
Yes, please.
Sir, how can we how can we do the above subtraction?
Yes, you just wanted to know like how we can utilize this complement function for the subtraction purpose, right? Yeah, this one you're talking about, this number, how we subtracted this one.
Yes, sir.
Let me explain you. Okay, so suppose I have 10000. This is the number. Okay, and I want to subtract it from 1101. Okay, so what will happen? I want to subtract 1 from 0. This is not possible to, I have to take borrow. Okay, so if I have taken borrow, so that number will become 10. Okay, this number will become 10. So 10 minus 1, that will give you 1. Okay, then what is happening here? Because now because I have this becomes 1, this becomes 1, so all this becomes 1 and this will become 0, something like that. Everyone all the digits will be shifted, something like that. So 1 minus 1 minus 0, that will give you 1, and then this is 1 minus 1, that will give you 0, and then 1 minus 1, that will give you 0. So this is what you are getting the results. So you have to take the borrow from the last digit where it is available, right? So because we are borrowing from the last digit, so this will become 0 and that will pass to the each digits, something like that. Simply just a simple technique just to understand how it has been done. See, suppose I have a number 1 1 1 1. If you see here, it looks like 1 1 1 1 has been considered here, and this becomes 0. If I somehow add 1, then what will be the result? Result will be like 1 plus 1, that will be 0. Then 1 will be carry forwarded, 1 plus 1 0, 1, then again carry forwarded, 1 plus 1 0, carry forwarded, 1 plus 1 0, carry forwarded, then this is 1. Yeah, this is what the number this is. Okay, so simply you can go in the both direction, either in the forward direction or in the reverse direction. Okay, so it is possible. So this is how we have subtracted this number from this one. You got the answer?
Yes, sir.
Fine.
Subtraction part में कैसे करेंगे?
Huh? Yeah, is there any query? Yeah, you can subtract it in both this way, right? So it's possible. Okay, so this is what we understand, that if somehow we are able to calculate r minus 1's complement, then we can calculate the r's complement as well by just adding 1 in that number. You can consider any of the example in the decimal number system or in octal number system or in the hexadecimal number system, and try to calculate r minus 1's and r's complement. Okay, so this is the homework for you. Just try and consider any of the number and try to calculate all those things. Okay,
Subtraction part होगा तो कैसे करेंगे?
okay. Now the important thing is how we can utilize these complements for the arithmetical operation. I just told you, because in the morning lecture we studied about what are the different arithmetical operations which we can perform with the binary number systems. We did some addition, some subtraction, then we performed some multiplication, then some division kind of things. Okay.
Excuse me, sir.
Yeah, please.
Sir, in the last slide, you said that the 1 gets borrowed, like if there is a 0 0, then it gets 1. But what if there is a fraction part, like 0.00001?
Yeah, so that fraction part is also we can do something like that only. Suppose I have a number 1000 something like that, or anything, something. Let me 01101, and then let us assume it is 01, and I have to subtract something like this. So, and some number is here. Let us assume 0101, something like that. Okay, you want to subtract this number from here, right? So in that case, because 1 minus 1, this is easily doable, we can do it 0. But here if we see here, this 0, we want to subtract this 1 from the 0. Okay, this is not possible, so I have to take the borrow from here, so that will become 10. Okay, 10 minus 1, that will become 10, and because this was 1, this will become 0. Just simply with what we do in the mathematics, like normal decimal number system, this is also the same, something like that. So now it becomes 0 minus 0, that will become 0, then 0 minus 1, then we have to borrow something from here, so this will become 10 minus 1, that will become 1, because I have borrowed 1 from here, so this becomes 0. So 0 minus 0, this will become 0 and 0. So this is the result. You got the point? Or
Here small n again donates the number of integral digits.
yes, yeah.
Sir, I think it should be 1010.
Where?
Sir,
oh,
the
sorry.
result-
Yeah. Sorry. Yeah, 1 minus 0, that will be 1. Yeah. So it should be 1010.10. So this will be the number. Okay. You got the answer? Who asked this question? Yeah. Okay, fine. So Sir, how we will subtract 0, 0, 1, 0 minus 1, 1, 0, 1. Okay, so we have to take some borrow. Yeah, so in that case, the negative number will come. So let me finish this part. Yeah, because Jayant asked one question. This is really very interesting. Like how we'll subtract 0, 0, 1, 0 from how we can subtract 1, 1, 0, 1 from 0, 0, 1, 0. Because 0, 0, 1, yeah, he asked the question something like 0. I have a number 0, 0, 1, 0, and I have to subtract 1, 1, 0, 1. Because if you see the this number is the bigger than larger than the above one. Okay, so to perform the subtraction operation of these kind of things, let me complete the application of this complement, and your answer, you will get your answer. Okay, then please wait for 5 minutes, you will get your answer. Okay. Okay, so fine. So let us try to consider some of the arithmetical operation with the help of complement. Okay, as of now, we have considered two kind of complements. One is the ones complement, and the second one is the twos complement for binary number systems. Okay, so let us first consider perform some subtraction operation using ones complement. Okay, so let us assume I have a number. Okay, so I have to subtract 1, 1, 1, 1. Let us assume this is a number from which I have to subtract some number, something like 0, 1, 0, 1. Yeah, if you see here, this subtraction is easily doable. Okay, you can subtract it perfectly. But how we can perform this with the help of the complement function? Okay, so to understand these things, let us try to write few things. Okay, whatever the number I have to subtract, just calculate the ones complement of that number. Okay, the first step is calculate the ones complement of that number which we have to subtract from the number. Okay, so if you see here, I have a number which is 1, 1, 1, 1. I have to subtract 0, 1, 0, 1. So I have to just first I need to calculate the ones complement of 0, 1, 0, 1. So the ones complement of 0, 1, 0, 1 is 1, 0, 1, 0. So this is nothing but this is the ones complement of, yeah, let me write it properly, otherwise ones complement of 0, 1, 0, 1 is 1, 0, 1, 0, and I have a number which is 1, 1, 1, 1. Initially I have to subtract 0, 1, 0, 1 from this number. After calculating the ones complement of this number, instead of subtracting, I have to add this number. Okay, if I have added this number, then what results I will get? Let us try to do that. 1 plus 0, that will become 1. 1 plus 1, this will become 0, and 1 will be carried forwarded. Then 1 plus 1, that will become 0, and 1 will be carried forwarded. 1 plus 1 plus 1, I will get 1, and 1 carry will be generated over here. Okay, so this is the result of this sum. Okay, if you clearly see this one, so this is the result. Now the important point of consideration, listen carefully, this is really very important. Okay, suppose I have to subtract some number, then what I have to do, with the help of ones complement, I have to first complement the number, then I have to add it instead of subtracting. Okay, now the second thing is, after adding the number, if carry is generated, okay, so this is what the carry is generated. Okay, this is the carry. Okay, if the carry is generated, in that case, what I have to do, I have to simply add this carry with the number whatever we have received. Okay, so I have to add this carry, then I need to find the results like 1 plus 1, 0. Then 1, that will become 1, 0, and 1. So whatever the number I am receiving over here, this is the result. This is the final result. And if the carry is generated and we have added this carry, so it indicates that if carry is generated, what it means? It means that the number is positive. Whatever the result we are receiving, that number is positive. So if I am subtracting 1, 1, 1, 1 minus 0, 1, 0, 1, I will get the result 1, 0, 1, 0. And by this process, we'll get the positive number. Okay, so this is the final result. And the carry which we have generated over here, we call it the end around carry. We call it the end around carry. This carry is end around carry. Now let us consider the second example. Okay, let us consider the second case. Suppose I have a number, just like Jayant asked, like suppose I have a smaller number and then I have to subtract the bigger number. Then how we can do that? Let us consider the second case. Suppose I have a number which is 1, 0, 0, 0, which is in the binary, and I have to subtract some number which is 1, 0, 1, 0. Okay, so this is what I have to do. Okay. Now, perform the same kind of things what we did for the previous example. Whatever the number I have, just I need to write it 1, 0, 0, 0. I have to calculate the ones complement of the second number. Okay. One zero, 1, 0. Okay. So the second ones complement of this number is 0, 1, 0, and 1. This is the ones complement. Then I have to add this number and try to see what is the result. 0 plus 1, that gives 1. 0 plus 0, this will give 0. 0 plus 1, this will give 1. And 1 plus 0, this will also give 1. Okay. Now, here if we see, no carry is generated. Okay. So if no carry, it means the number is negative. Okay. If no carry, then number is negative. Now what is the exact number? Okay. So if you see here, no carry. And that indicates the number is negative. Okay. Now, because whatever the results we are getting, this results is not exact result. Okay. Whatever the results we have received here, 1, 1, 0, 1, this is not the exact result. Now, what I have to do, I have to calculate the ones complement of this result, whatever we have received. Okay. I have to calculate the ones complement of this result. And after calculating the ones complement, the number will be 0, 0, 1, 0, and this is the negative number. So this is the actual result. Okay. And this is what we can see here. This is the ones complement of true result. Okay. So this is nothing but this is the ones complement of result. Okay. So this is how we can perform the subtraction operation with the help of ones complement. Is there any doubt? Jayant, you got your answer? Okay, perfect. So this is how we can perform the subtraction operation with the help of ones complement. Okay, so 2 points that you have to remember. The first point is if the carry is generated, immediately we can say the number is positive. Okay, and if that carry will be added again with the results whatever we got. Okay, and that will become the final result. If there is no carry, then the results which we are receiving, that is the complemented form of the result. Then we have to complement it and we will get the final results. So this is how the computer works. Okay, in computer we cannot subtract it. We have, if I have to subtract two numbers, then we have to perform some arithmetical, like this kind of operation, complement kind of things we have to use it. Okay, and that we can do it, and we can just compare whether there is carry or not, and based on that we can say whether the result is positive or negative. Okay, so this is the final one. Now let us talk about how we can perform some operation with the help of 2's complement. If I'm talking about the 2's complement, then how we can do that. Okay, so let us try to consider the same examples which we have used. Okay, so let me check what I used. 1 1 1 1 minus 0 1 0 1. Okay, with the help of 2's complement, how we can do that. Okay, so let us try to do that. First case, I have to subtract some numbers from 1 1 1 1. That number is 0 1 0 1 that we have considered in the previous one. Okay, what I have to do, I have to write the number, the first number as it is, 1 1 1 1, and I have to calculate the 2's complement of the number. Okay, so I have to calculate the 2's complement of 0 1 0 1 is like 1 0 1 0, so that will become 1 0 1 1, and I have number like 1 1 1 1. Okay, so this is what, then add it. Okay, after adding this, like 1 plus 1, that will become 0, then carry will be forwarded. 1 plus 1 plus 1, that will become 1 more carry here, 1, then 1 plus 1, that will this will give you the 0, and then carry 1, then 1 plus 1, and then 1 carry will be generated. Okay, now if I'm considering the 2's complement, in that case, if the carry is generated here, if we see here, the carry is generated, this is the carry. So what operations I have to do? This carry indicate that the number is positive. Number is positive. After performing this 2's complement, we have, if the carry is generated, then we can say that the number is positive. And what operation I have to do? The operation I have to do, like I have to discard this carry. Okay, I have to remove this one. I do not need to consider this carry. Okay, I have to discard it. Okay, and if I have discarded, the actual number will become 1 0 1 0, and this is how we can calculate we can subtract the number from here. If we see the previous slide, we are getting the same result. Okay, now let us try to consider the second case. Okay, if I'm considering the case 2, when I am subtracting a larger number from the smaller number, then how we can do that? Okay, suppose yeah, let me consider the previous slide. What was the example? Yeah, the example was 1 0 0 0 minus 1 0 1 0. Okay, so 1 0 0 0 minus 1 0 1 0. I have to subtract this one. Then what I have to do? Simple thing is, like the first write the number, whatever we have, that is 1 0 0 0. Then I have to calculate the 2's complement. One zero one zero. If I have to calculate 2's complement, 1's complement will be like 0 1 0 1, and then if I will add 1, then that will become 1 plus 1, that will be 0 1 1 0. So this is the 2's complement, right? So this is the 2's complement of 1 0 1 0. So 0 1 1 0, and I have to add this number. Okay, after adding this number, what is the result? Let us try to see. 0 0 plus 1, 1, 0 plus 1, 1, 1 plus 1, 1. Now the thing is, if no carry, what it means, whatever the results we have received here, this result is the negative result, and it is in the 2's complement form of the true result. If we see the previous one, if there was no carry, we say that the result is negative, and whatever the results we got, that was the 1's complement of the actual result. But here, if no carry is generated, what it indicates, it indicates that this number is nothing but this is the 2's complement of true result. Okay, so this is the 2's complement of the result. Okay, so okay, then if it is the negative, then what I have to do, I have to perform the 1's complement, then add 1, and I will get, so 1's complement will be like 0 0 1 0 0 0 0 1, and then I have to add, so that number will become 0 0 1 0. Okay, so the actual result will be 0 0 1 0, and this is negative. So this is actual number. Okay. So is there any doubt how we have calculated all these things? In case of any doubt, you can ask the question, right? So I will answer. Anyone? How we have utilized the 1's complement and the 2's complement for the subtraction. So this is really very important. Okay.
At last, we again find out the 2's complement again. No?
Yes, because whatever the results we got, like in the second case, whatever the results we got, if there is no carry, it means the result is negative, and it is in the 2's complement form. Okay, so if it is in the 2's complement form, then I have to convert it into the actual result. So to make it in the actual result, that just I have to, there are two ways to do that. How we calculate the 2's complement? Whatever the number I have, let us assume 1010, this is the number, and if I have to calculate the 2's complement of this one, so first I have to complement each digit, so 0101, and then I have to add 1. Okay, so this will become like the result, 1 plus 1, that this is 0 1 1 0. So this is the result. If I have to get this number, then what I have to do? We can do with the two way. Either subtract -1 from here and then complement the result. So then you will get this one. But because in the digital system, subtraction is not possible. Okay, that is why we are doing all this exercise. So for that purpose, if you can calculate the 2's complement of that result again, then you will get the actual result. Okay, so this is how you can do it.